3-Eye Atlas is visible once again, re-emerging from behind the sun after weeks of silence. The most anomalous interstellar object ever detected has returned from Perihelion, and it's glowing, bluer than our own star.
It follows a path that is aligned with the ecliptic plane of the planets around the sun, and it had additional anomalies, altogether 10 of them.
Not reflecting sunlight, but emitting light as though powered by something far hotter than the sun's 5,800 Kelvin photosphere. Harvard astrophysicist Avi Loeb has now classified this as the 10th impossible property of an object that, by every known statistical model, shouldn't exist at all. And here's why that matters. A single color measurement may point to a phenomenon or a technology we've never encountered.
This morning we have a report that the object got much brighter than expected, and moreover, the color of the object is bluer than the sun. And that's very surprising, because usually when there is dust around an object, it should make it red.
10 statistical impossibilities are converging at once, culminating in a brightness signature that seems to challenge the laws of physics themselves. December 19th marks the moment of truth. Most comets glow only by reflecting starlight. But what happens when an object shines with a color temperature hotter than the star it orbits? Pay attention to the cascade of contradictions that follows. Each one narrows the list of possible explanations to something increasingly extraordinary.
It came closest to the sun yesterday. Unfortunately, we can't look at it from Earth because the Earth is on the opposite side of the sun. That could have also been a hint of a technological design.
On October 29th, 2025, 3-Eye Atlas reached perihelion, its closest pass to the sun, just 54 million kilometers away. At that range, 770 watts of solar energy strike every square meter of its surface. Ordinary comets disintegrate under that kind of thermal stress, but 3-Eye Atlas did not. Here's the strange part. Earth-based telescopes saw nothing. The object passed directly behind the sun, vanishing from our line of sight during solar conjunction. Fortunately, 3 space-based observatories occupied positions where the sun didn't block their view.
800 degrees Kelvin above absolute zero, and it's very difficult to keep a surface hotter than that. In fact, an object at the distance of 3-Eye Atlas from the sun could only be 20 times cooler than the sun, so it should be redder.
Stereo A, orbiting slightly ahead of Earth, captured images with its COR2 coronagraph. SOHO, stationed at the gravitational balance point between Earth and the sun, monitored continuously using LASCO instruments, and GOES 19, a newly launched meteorological satellite from 2024, recorded fine detail from geostationary orbit with its CCOR1 coronagraph. Together, these 3 perspectives documented something no ground-based telescope could possibly witness.
If there's more energy going out than in, it means that there's energy boost coming from whipping around the sun, and that requires intelligence.
Their September and October data streams revealed a brightness surge unlike anything ever recorded from an Oort cloud comet. CCOR-1 detected a luminous envelope extending nearly 300,000 kilometers around the object, comparable to the distance between Earth and the Moon. Imagine that, a glowing sphere the size of the Earth-Moon system itself. This matched the vast carbon dioxide plume detected in August. Yet even in peer-reviewed studies, scientists admit the mechanism driving that energy release remains obscure. Comets brighten as they near the sun, yes, but not like this. The rate of increase has no known natural precedent. Then came the data that changed everything. Both the LASCO and CCOR1 coronagraphs registered 3-Eye Atlas as distinctly bluer than the sun. Loeb's analysis was unequivocal. This is extremely surprising. Normally, dust scatters sunlight toward the red end of the spectrum. Surfaces cooler than 5,800 Kelvin emit redder wavelengths. Earlier observations had shown 3-Eye Atlas with a reddish tint. Now, at perihelion, that hue had shifted unmistakably blue, and hidden within that color shift lies a puzzle no conventional comet model can explain. Blue light indicates higher temperature. The shift raises a question Avi Loeb poses directly, without speculation or hesitation. Does 3I Atlas employ an energy source hotter than our star? If dust scattering and reflected sunlight can't explain it, then the source must be internal. But natural objects don't generate power that burns hotter than stellar photospheres. That leaves us with two unsettling options. Either our models of thermodynamics are catastrophically incomplete, or we're observing technology. This 10th anomaly now joins a growing list of impossibilities, each one tightening the vice around conventional astrophysics. Let's review what shouldn't exist, but does. 3I Atlas arrived along a trajectory aligned within 5 degrees of the ecliptic, the flat plane where planets orbit. Objects ejected randomly from other star systems should approach from any angle, like meteorites striking a spinning plate from above or below. The probability of such perfect alignment by chance, just 0.2%, the cosmic equivalent of threading a needle in total darkness. Then, during July and August, something unprecedented happened. 3I Atlas expelled a jet of material directly toward the sun. Every comet ever observed behaves in the opposite way. Radiation pressure from starlight always blows tails away from the source, like hair swept backward by wind. But 3I Atlas broke that law, as if sprinting into a storm, with its own tail blown into its face. Most will overlook this subtlety, but it's the smoking gun linking mass, velocity, and something that begins to look like intent. This object is 1,000,000 times more massive than Oumuamua, 1,000 times larger than Borisov, yet it moves faster than either. Imagine a fully loaded cargo ship outpacing a fleet of speedboats. In celestial mechanics, mass and velocity are inversely related. Heavier bodies move slower. But 3I Atlas defies that fundamental correlation. Then comes the timing. It passed near Mars, Venus, and Jupiter, each encounter executed with remarkable precision. Yet it remained hidden from Earth during the most critical observation window, its perihelion. It's as if a tourist visited 3 major landmarks while managing to avoid every security camera at the main airport. The odds of that choreography are astronomical, literally. Spectroscopic analysis deepened the mystery. The nickel-to-iron ratio matches industrial alloys, the kind produced in terrestrial foundries, not the chaotic mix of elements expected in ancient cosmic ice. Traditional comets are often described as dirty snowballs, composed of 80 to 90% frozen water. But 3I Atlas contains only about 4%, drier than the Atacama Desert. It's not a snowball at all. It's an iceberg made of metal, and the surprises kept coming. Polarization measurements revealed a light signature absent from every known natural object, including Borisov, the only other confirmed interstellar comet. Taken together, these 3 anomalies, composition, dryness, and polarization, force a re-evaluation of what we even classify as a comet. And then there's its point of origin. 3I Atlas arrived from the exact celestial coordinates that produced the legendary WOW signal in 1977, the most credible candidate for a extraterrestrial radio transmission ever detected. 2 separate events, decades apart, yet from the same precise patch of sky. It's like firing 2 arrows, 48 years apart, and both striking the same bullseye. Now, with the perihelion blue shift data added to the record, anomaly number 10 is complete. Avi Loeb's interpretation is measured but unmistakable. The appearance of 3I Atlas bluer than the sun is very surprising. If its surface were merely heated by solar radiation, it should glow redder, not bluer. The temperature gradient is inverted. Therefore, something internal must be generating photons of higher energy than the surrounding radiation field. Behind the scenes, scientists debated whether to release the probability analysis. Here's what nearly remained unpublished. When you multiply the odds of each individual anomaly, the numbers collapse into impossibility. Ecliptic alignment, 0.2%. Sunward jet, under 1%. Mass velocity paradox, low single digits. Timing precision, fractions of a percent. Factory-grade alloy composition, negligible probability. Unique polarization fingerprint, unquantified but extreme. Directional correlation with the WOW. Signal astronomically slim. Dryness inconsistent with any comet model. Blue stellar temperature emission. Thermodynamically forbidden for passive bodies. Combine them all, and the cumulative probability becomes less than 1 in 10 quadrillion. That's worse odds than winning 15 consecutive lotteries. It's more likely you'd be struck by lightning twice in 1 year. While holding a royal flush, you didn't deal. When probability collapses to that degree, Occam's razor reverses. The simplest explanation becomes the one we've avoided. If Avi Loeb's assessment holds true, then 3i Atlas may possess technology capable of generating sustained energy at temperatures exceeding the sun's own photosphere. That level of energy control implies mastery, fusion, antimatter, or perhaps an entirely new branch of physics. Civilizations capable of wielding such power wouldn't appear by accident, nor drift through space without purpose. Every measurable property of 3i Atlas, its trajectory, timing, composition, and thermal behavior, points not toward randomness, but intent. Across the globe, observatories remain locked in continuous monitoring mode. High-frequency radio arrays listen for structured transmissions. Optical telescopes track brightness variations that could signal artificial modulation. Infrared networks search for the heat trail of propulsion. Even Congress is involved, facilitating the release of classified high-resolution imagery captured on October 2nd to the scientific community. Researchers are combing through the data, searching for signs of course corrections, possible probe deployments, or signals inconsistent with natural motion. The sensors are live, the data streams are open, and the countdown has begun. Here's why December 19th carries historic weight. On that date, 3i Atlas emerges from behind the sun, its first visible return since conjunction. Twilight observations from Earth will resume within days, marking its closest approach to our planet. The Hubble Space Telescope, the James Webb Space Telescope, and dozens of ground-based observatories will all lock onto a single cosmic target. If the object alters course, emits structured signals, or reveals geometry inconsistent with natural fragmentation, we could be witnessing the first direct evidence of engineered technology beyond Earth. But if nature somehow explains these 10 anomalies, then our understanding of physics will need to be rewritten from the ground up. Either outcome reshapes everything we know. We're not studying a relic from the distant past, nor chasing whispers from deep space. We are observing, in real time, an object whose behavior statistically requires technology, glowing with energy that surpasses our own star. Right now, as you watch this, spacecraft instruments are repositioning. Observation windows are locked. Teams across 6 continents, led by Avi Loeb and fellow astrophysicists, are parsing photon counts and spectral lines with unprecedented precision. 50 days separate us from the December flyby. 50 days to answer one of humanity's oldest questions. Are we alone? History isn't written in textbooks tonight. It's streaming live, wavelength by wavelength, through coronagraphs and radio dishes aimed at an impossible visitor. Whether 3i Atlas is the strangest comet ever born, or a machine powered by physics beyond our sun, one fact remains inescapable. Nothing natural should glow blue at Perihelion, and yet something does. We're about to discover what technology beyond our sun truly looks like when it drifts within reach of human eyes. If you found this exploration as fascinating as we did, don't forget to like, subscribe, and stay tuned, because what happens next could redefine everything we thought we knew about the universe. See you on the next one.